Welcome to CausalPulse at Bosch. Our multi-agent Copilot is designed to seamlessly handle data processing, anomaly prediction, causal discovery, and root cause analysis, all in one intelligent system. In this demo, we're working with data from the Henson plant in South Carolina, USA. This facility is dedicated to producing planar oxygen sensors with a special focus on the precision grinding of the planar sensor element, a critical part of advanced automotive manufacturing. With CausalPulse, operators and engineers can interact with data as if they were having a conversation. First, the operators can upload a dataset, or they can directly connect with PLCs to get real-time data. Instead of navigating dashboards or writing complex code, they can simply ask for what they need. For instance, the Copilot can clean and pre-process the dataset automatically. Pre-processing agent cleans the dataset by removing empty rows or columns, standardizing object types, imputing missing values, label encoding non-temporal string features, and finally saving the cleaned data along with a summary of changes. Pre-processing agent communicates with the background information agent to get semantic information for the variables. Recommender agent suggests the next best actions based on the current system state and guiding operators toward optimal decisions. It can perform causal discovery, revealing hidden dependencies between process variables. This causal graph shows how control variables affect observation variables in the PSE dataset and how the observation variables causally influence each other. The causal graphs are enriched with domain knowledge from the grinding process, incorporating the ordered sequence of grinding steps to ensure more accurate and process-aware causal reasoning. When questions arise on production quality, CausalPulse delivers direct answers. It can determine the anomaly status of specific process conditions, such as when a sensor reads C1 equals 0.107 for part type F0, 0VS, 0E216, or when C1 and C2 take on certain values together. It can even evaluate more complex scenarios, like when D2 measures 0.397 while E1 is 0.104. But CausalPulse goes further. It doesn't just flag anomalies. It helps uncover why they happen. For example, the system detects an anomaly at E7 and traces multiple causal paths back to the root causes, including D1, D3, and F1, each ranked by causal significance, showing how strongly each factor contributes. In this example, the system detects an anomaly at E4 and identifies its root causes as grind depth 4 and set angle 3, both of which are control variables driving the observed deviation. Here is an example where the system detects an anomaly at E9 and traces multiple causal paths back to the actual root causes, including F4, D3, E4, and D4. And when you need a broader overview, CausalPulse can instantly provide pre-computed dataset statistics. The pre-computed dataset statistics show how each node in the causal graph is modeled. Root nodes are captured using empirical distributions, while non-root nodes are explained through additive noise models or classifiers, depending on whether the data is continuous or categorical. In total, 25 nodes were analyzed, each assigned the best fit model, providing a rigorous statistical foundation for root cause analysis. Finally, let's look at the architecture of CausalPulse. Our setup is built around specialized agents, each designed to handle a specific task, with seamless communication enabled through the Model Context Protocol and Google's Agent-to-Agent protocol. A workflow unfolds in 3 stages. Stage 1 is agent card registration. Here, every agent registers their agent card on the central server. In the MCP A2A architecture, this agent card JSON defines the agent's identity, capabilities, endpoints, and policies, ensuring that other agents know exactly how to interact with it. Stage 2 handles the agent interactions and data flow. Once registered, agents communicate and collaborate to process the data, execute anomaly prediction, perform causal discovery, and carry out root cause analysis. Stage 3 handles post-process chaining. After the primary agents complete their tasks, the recommender agent is activated. It analyzes the current system state and suggests the next best actions, guiding operators toward optimal decisions. Together, these stages form a flexible, modular, and intelligent multi-agent architecture, the foundation of CausalPulse.